So what we're going to look at here in the next section has to do with some different things involving probability rules, and a lot of the rules that come up here are things that hopefully you should be somewhat familiar with. So some terminology here first. The first thing here would be with what's called sample space. And the sample space of a chance process is the set of all possible outcomes. So for instance, if you were going to choose a card from a standard deck of cards, the sample space would be the 52 cards that are in the deck. And then there's also what's called a probability model. And a probability model is basically just describing some sort of chance process that has essentially two pieces to it. One is the sample space, and then the probability for each of the outcomes. So if you're asked to find what a probability model is, what you first want to do is you want to list all the possible outcomes of a chance process, and then for each of the outcomes you want to list what each of the individual probabilities would be for that. So just an example here, and it says give a probability model for the chance process of rolling two six-sided dice, one that's red and one that's green. So these are all the different possibilities, all this right here, all the different possibilities that could occur when you roll two different six-sided dice. So, you have a 1 and a 1, a 2 and a 1, a 3 and a 1, 4 and 1, 5 and 1, 6 and 1, and then we could go over to here, a 1 and a 2, 2 and a 2, etc., etc., etc. So whenever you roll two dice, there are a total of 36 possibilities. So the sample space, or the value of the sample space, would be 36 outcomes. And then it says, since the dice are fair, each outcome is equally likely, meaning that the probability of each one of these individual possibilities occurring is 1 out of 36. So a probability model, it allows you to find the probability of any collection of outcomes. So the other thing, just from terminology standpoint with probability, that we talk about is an event. And basically an event in probability speak is what it is that you're trying to find the probability of. So an event is any collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually designated with capital letters, A, B, C, etc., etc., etc. If A is an event, we would write the probability of A as this right here, sort of P with the A in the parentheses. And then in the dice rolling example, it says, suppose we defined event A as the sum is 5. So here's all the different ways you could roll a 5. A 1 and a 4, 2 and a 3, 3 and a 2, 4 and a 1. So there's 4 different ways you can roll a 5. So since each outcome is 1 out of 36, we would say that the probability of rolling a 5, or probability that we would roll two dice and the sum is a 5, is 4 out of 36. Then this question here at the bottom, it says, suppose event B is defined as the sum is not 5, meaning you roll something else, and that would be event B. What's the probability for that? So, and this gets into this whole business with what's called the complement, which we'll talk about here in a moment. But if the probability of rolling a 5 is 4 out of 36, and the entire probability of the sample space equals 1, then what we can do to find that the sum is not 5 is we can simply just say 1 minus that the sum is 5. So we would do here 1 minus 4 over 36, which comes out to be 32 over 36. So a couple things here just with tips involving probability. So there's a lot of different ways you can write your answers to a probability question. You can write it as a fraction, you can write it as a decimal, you can write it as a percent. We're going to spend most of our time focusing on fractions because that's the easiest way to write it. So one thing just to keep in mind with this is that if you're expressing your probability as a fraction, it is acceptable not to reduce. And the reason that we don't reduce is because reducing sometimes takes away the context of the problem that we're talking about. So in particular, in the denominator. So the denominator will always give you, if you write your answer as a fraction, will always give you what the sample space is. And sometimes it's just easier for us to leave the fraction as it is so that we can see in the context of what we're doing what the values in the problem are. So just some different basic rules here for probability. One is the probability of any event is a number between 0 and 1. All possible outcomes together must have probabilities whose sum is 1. If the outcome and the sample spaces are equally likely, the probability that event A occurs can be found using this formula here. And this is the one that you guys probably are familiar going all the way back to, I would say, middle school. And that is the probability of A equals the number of outcomes corresponding to event A over the total number of outcomes in the sample space. This one here, the probability that an event does not occur is 1 minus the probability that the event does occur. That's referred to, you might want to make a note of this, that's referred to as the complement rule, which we'll talk more about later. And then if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. And we're going to talk a lot in the next couple days about this whole business of events that have no outcomes in common. And this at the bottom here, mutually exclusive events, and this sort of refers to this whole business of no outcomes in common. So two events are what are called mutually exclusive. Sometimes it's referred to as disjoint, if they have no outcomes in common and can never occur together. So just some other sort of rules here, and this has more just sort of some notation things here. So for any event A, probability must be between 0 and 1. If S is the sample space in a probability model, that means that all of the outcomes together must equal 1. Here's the formula for probability. We just talked about that. Here's the complement rule. Okay, and the complement of an event is the probability that an event does not occur. And we represent the complement of an event with this little c here. So if you want to find the probability that something doesn't occur, you simply just do 1 minus the probability that the event does occur. And then here's sort of the first mathematical rule that we're going to look at for probability, and it's the addition rule for what are called mutually exclusive events. So just keep in mind, mutually exclusive events are two events that have no outcomes in common. So if we wanted to find the probability of A or B if events were mutually exclusive, all we would simply do is just add their individual probabilities. Probability of A plus the probability of B. So this example here, it says distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking distance learning courses for credit and record the student's age. Here is the probability model. So they broke up their age groups the following way. So they have the 18 to 23 group, the 24 to 29 group, the 30 to 39, and the 40 and over. So within the 18 to 23-year-old group, 57% of those students were taking distance learning courses. In the 24 to 29 group, 17% of those were taking distance learning courses, 14%, and then obviously 12%. So the question here says, show that this is a legitimate probability model. So for it to be a legitimate probability model, it must list all the possible outcomes, and then the probabilities of each of those outcomes collectively must equal 1. So you can see here that they've listed all of the possible outcomes because, let's just say in theory, that someone has to be a minimum of 18 years old to be a college student. And then the 40 and over covers pretty much everybody else. So those are all the possible outcomes. And then if you add the probabilities, okay, they all add up to be 1. So that's what makes this a legitimate probability model. It lists all the possibilities, and the probabilities for all those possibilities adds up to be 1. And then B says, find the probability that the chosen student is not in the traditional college age group, which would be 18 to 23. So now, because it says that they're not in the traditional age group, that's the complement rule. So there's two different ways you could actually go about this. One is you could say 1 minus the probability that they are in that age group, which would be 0.43, or you could simply just add the values of the groups that are not in the 18 to 23 group. So if I added 0.17 plus 0.14 plus 0.12, that would also get me the 0.043 there as well. So similar example here, and it says choose an American adult at random and define two events. Event A is that a person has a cholesterol level of 240 milligrams per deciliter of blood or above, and that's considered to be high cholesterol. And then there's event B, and that is the person has a cholesterol level between 200 and 239 milligrams per deciliter, and we consider that to be borderline high cholesterol. And it says, according to the American Heart Association, the probability of A is 0.16. The probability that you would choose an American adult at random and they would have high cholesterol is 0.16. And then the probability of B is 0.29, meaning the probability that you would choose an American adult at random and they would have borderline high cholesterol is 0.29. Question 1 says, explain why events A and B are mutually exclusive. So the events are mutually exclusive here because, remember, once again, mutually exclusive is two events that have no outcomes in common. So these two events are mutually exclusive because someone cannot have high cholesterol and borderline high cholesterol. They would have to be in one group or the other if they were in even either one of those groups. So that's why these events would be considered mutually exclusive. Question 2 says, say in plain language what the event A or B is, meaning what is the probability of A or B. So if the events are mutually exclusive, which is what this says here that they are, to find the probability of A or B, we simply just add the individual probabilities together. So I would do here for the individual probabilities, I have 0.16 and 0.29. So if I added 0.16 plus 0.29, that's where this 0.045 comes from. Or I'm sorry, 0.45. And then question 3 says, if C is the event that a person chosen has normal cholesterol, what's the probability of C? So let's assume for the basis of our argument here, question 3 is that either there's only 3 categories for cholesterol levels. There's high, borderline high, and normal. So this would be the third category. So to find what the probability is, I would simply just do 1 minus the probability that someone was high or borderline high, which is what I'm going to put in here. So if I did 1 minus 0.45, that's 0.55. And that's just some different things there with the complement rule. So one of the things that we'll look at next in terms of probability rules, we'll get into some different things with what's called the general addition formula for events that are not mutually exclusive. We'll also take a look at some different things involving probabilities with two-way tables and also some different things with Venn diagrams.